Hello students. In the previous video we have discussed about the kinematics of motion along a straight line and in that video we have discussed some terms. हमने कुछ terms discuss किया था like frame of reference, position and displacement. So now in this video, before proceeding we will do one or two questions related to displacement. As you can see in the diagram, a point object or a particle starts from point P and reaches to Q via this path. This is semicircular path of radius R. So in this context, the displacement in this case, displacement is equals to, we have defined the displacement is just the straight line distance between 2 points. So the displacement will be simply, it is the distance from P to Q, straight line distance R, and this is R, simply 2R, and the distance, that is the total path length, is equals to pi R, the perimeter of this semicircle. One more question. Actually, in this question, I'm basically going to discuss one type of question, one concept of the displacement. See, it is not necessarily that the displacement is always given in terms of 2 points. Maybe the displacement is given as a function of time. That with the time how the position is changing, and we may have to find the displacement. For example, suppose my position as a function of time is given. It is 2t square plus or plus 2. So for example, this is the position as a function of time is given, and we have to find the displacement during t is equals to 1 second to t is equals to 3 seconds. Suppose we have to find the displacement from t is equals to 1 second to t is equals to 3 seconds. Then in this case, how we will find the displacement? We will find the initial position x at 1 second by putting the value of 1 here at a place of t. So it is 2 into 1 its whole square plus 2, that is 4, and the x at a time 3 second, 2 into 3 its square plus 2, which is equals to 9 into 2, 18 plus 2, 20 meter. So this is the position at t is equals to 1 second, and this is the position at t is equals to 3 seconds. So the displacement from 1 to 3 seconds we can simply subtract. We can take the final position minus initial position. So displacement s is equals to x at 3 second minus x at 1 second. So 20 minus 4 is equals to 16 meter. So the displacement is 16 meter. So there is two types of question regarding the displacement. Either the path is given or the two sharp location is given from the starting to end, or maybe instead of giving the two sharp position, a relation or a function of position with respect to time is given, and you have to find the displacement. So you can find like this if it is given like this. So now the next term we will define one more term, velocity. Now we will define velocity. See, what is the velocity? Now I'm going to introduce time. See, we are measuring the displacement, but if there is a question that this displacement is covered in how much time, means ki how much time is taken during covering of this displacement, then there is the question of rate, that is the rate of change of displacement, and that is known as velocity. So first we define, it is defined as rate of change of displacement. So it is defined as rate of change of displacement. That is how fast or how slow this a particular displacement is covered. That is known as velocity. So first point about it, it is vector quantity. It is vector quantity. Its SI unit is meter. SI unit is meter. Third point, it may be positive, negative, or zero. As it is a vector quantity, so it may take any sign, maybe positive, maybe negative, or zero. So this is about the velocity. Further, this velocity can be defined, can be divided in two parts, two categories. Velocity can further be divided in two parts: average velocity and instantaneous velocity. Instantaneous velocity. See, since the velocity is the rate with which the displacement is being covered. So the rate may be of two type, from start to end or during a given span of time. What was the rate? There may be a question, during a given span of time from the initial time to final time, what was the overall rate? That is the average velocity. Or the rate may be asked like what was the rate at a particular point of time. That is what was the rate with which the displacement is being covered at a particular point of time or instant. That is known as instantaneous velocity. So first we will deal with average velocity. Average velocity. So it is nothing but the total displacement covered by total time taken. Directly I am not writing the definition, I am just writing expression. Average velocity, V average is equals to total displacement divided by total time. Total displacement by total time. So to clear the idea of average velocity, we will do one or two questions. We will clear it via questions. So first of all, we will do one question regarding average velocity, which this type of question is frequently asked in the exams. Suppose a point, object or a particle start from a point say P and reaches to a point say Q, and half of the displacement it covers with a particular speed v1. It covers half of the set is x. First half it cover with v1 and second half it cover with v2. So what is the average velocity? What is the average velocity from starting to end? From P to Q, what is the average velocity? This is my question. So very simple. We will not do any more. Just we will apply this definition. To find the average velocity, I need two things: the total displacement and total time. So displacement is given. Say let it is x and x 2x. So total displacement is equals to 2x. Fine. I let it something x and x because in the question it is given it is 2 equal half. Now I will find the second thing, time, total time. So if say कि in the first half it takes time t1 and in second half it takes time t2. Here it takes time t1 and here it takes time t2. Then t1 is equals to x by v1 and t2 is equals to x by v2. So total time is equals to t1 plus t2, that is x by v1 plus x by v2. Fine. Now we have the total displacement, we have the total time, and just now we will take the ratio of these two. I will get the average velocity. So V average is equals to 2x upon x by v1 plus x by v2. X will be common and cancel out, so it is 2 upon 1 by v1 plus 1 by v2, and finally V average is equals to v1 v2 LCM, so it is twice v1 v2 upon v1 plus v2. So in this case, my average velocity will look like this: 2 v1 v2 upon v1 plus v2. Now, now the next one more type of average velocity. Suppose a particle moves from P to Q such that for 2 equal half of time, first half of time it travels with v1 and the second half time it travels with v2. Be careful here, the division is made on the basis of time, not the equal displacement. Here first half of time it covered with v1 and the second half time it covered with v2 during the journey. And again we have to find the average velocity from starting to end. Then again we will do the same thing. We will find the displacement time and we'll take the ratio. So this time total displacement is equals to 1. In the first t it will cover v1 into t is equals to v1 t plus v2 t. v1 with time t, so v1 into t this much, and v2 with time t, then v2 into t. So total from p to q it is v1 t plus v2 t. Now total time it is itself given half of time, so t and t 2t. Total time is equals to 2t. Therefore v average in this case is equals to v1 t plus v2 t upon 2t. That is v average is equals to v1 plus v2 divided by 2. So in this case average velocity will be look like this, v1 plus v2 by 2. So these are the two questions of average velocity which is asked most of the time in many exams. Or in the similar case, we can divide it into 3 half also. 3 equal halves, 4 equal halves, similar. So the same concept will be applied in this video up to this, and in the next video we will discuss instantaneous velocity and speed. Fine.